Good afternoon. Welcome to the third episode of Pipelines 101. I'm Shelley Robbins. Let me make sure my audio is on. Okay, I think it is. I'm Shelley Robbins, Energy and State Policy Director for Upstate Forever. We are an environmental advocacy nonprofit that serves the 10-county upstate region of South Carolina. And we work to balance growth with natural resource protection. So if you tuned in to episodes 1 and 2, you're going to get a little bit of a repeat on the background, but we have some new folks. So why are we here? Why are we offering this webinar series? Well, in 2016, Dominion Resources proposed a 55-mile natural gas pipeline that wound up impacting 4 upstate counties and more than 70 stream and river crossings, including some areas that Upstate Forever had identified as conservation focus areas years before. We intervened in the certificate proceeding and were represented by the South Carolina Environmental Law Project and specifically by Michael Corley, who presented an overview of the FERC process in episode 1. We also utilized the talents of David Sly of Wild, Virginia on the the 401 certification, and he presented in episode 2. And we were also helped by our own GIS manager, Katie Hodel, and David will be back with Katie to share additional expertise on episode 4 on Wednesday. Now, ultimately, that pipeline was granted a certificate of public convenience and necessity by FERC, the Federal Energy Regulatory Commission. It was built and is now in service, but it caused significant problems along the way. And we recognize that given the current market and regulatory structure, there will be many additional natural gas pipelines proposed in the Southeast, and we want to share what we've learned. When we started our intervention process, we had no background whatsoever in interstate natural gas pipeline regulation, and the learning curve was really steep, but we learned as we went along. And once the process was finished, we realized that other communities could benefit from a crash course on this issue. So we're recording each webinar and making the recordings as well as the PDF slide deck available on our website, and we'll try to make it easily searchable on the internet as well. And the series was made possible by funding from a private donor to whom we are eternally grateful. Now, episode 1 was an overview of the relevant statutes, such as the Natural Gas Act, NEPA, and others, and the FERC certificate process, as well as a lesson in navigating the FERC website. Episode 2 was a deeper dive on the nationwide 12 permit and 401 water quality certification processes. Both of those episodes were text heavy on the slides by necessity, so today I'm going to give your eyes a break. Today will be much more visual also by necessity. We'll start with, that's me. I'll give you an overview of natural gas pipeline construction and what different water body crossing techniques look like, as well as some of the common problems that we've seen. And I'll explain Dekatherms and how you can fully use them to fully understand how big a pipeline is beyond just its diameter, what size it is meant to serve, and then you can use this understanding to determine for yourself if capacity need actually exists. And I'll also talk about natural gas exports and prices. Exports are increasingly driving pipeline construction, and experts believe that exports will drive domestic gas prices up in the long run. And I'll give you a quick tutorial on how to find national energy infrastructure on the EIA website. And then in the final episode on October 31st, we will talk about the impact that pipelines have on conservation easements and on timber properties. And we learned a lot about those with our process. And I'll share some right-of-way contract best practices that our upstate timber owners were able to negotiate. And we will also share the GIS process that we use in order to identify all of the property owners along our 55-mile pipeline, because neither FERC nor the pipeline builder is going to give you that information. We use that information to communicate with them regarding their rights, and we also made sure they were aware of some meetings and some input opportunities. And then also in that last episode, David Sly will share some of the various monitoring tools and programs that other communities can learn from and use. So we will get started. You can type questions in the question box on your drop-down menu on the right. I will probably hold these to the end since this is just me today. And you can always email me if I miss something. So we will start with a little bit of jargon. And these are just words that became really common to me during the process, but that aren't necessarily intuitive when you first start in on this. And the first is alignment. All that means is that's the pipeline path. So when they refer to the alignment, they just mean the route. They're not talking about aligning it with anything in particular. So it is the alignment is the pipeline route. Pigs are fun. There are smart pigs and dumb pigs. Pigs are, some people have said they refer to pipeline inspection gauges, but they don't. That's made up. They existed long before they were able to inspect any pipelines. So they were named there, that little tool down there on the right. Dumb pigs, all they do is shoot through the pipeline and clean it out. Smart pigs have sensibility, are able to sense. Some use sound waves or magnetic technology to sense problems or weaknesses in the pipeline. Those are smart pigs. And you're seeing them increasingly. The reason they're called pigs is because back in the old days, they squealed when they went through the pipeline. So it is, pipeline inspection gauge kind of helps you remember what it does, but that's not why it's named that. And that's pretty much all we'll talk about pigs, except for pig launchers and pig receivers, which is also great fun. And then ECD, that is an erosion control device. You'll frequently see a reference to an ECD, erosion control device. I'll show you some pictures of those, and particularly where they've failed later on. And HCAs, that is a high consequence area. Essentially, it's a blast zone. It is an area, they have different classes 1 through 4 along the pipeline. Class 1 is sort of the lowest risk. It is considered rural, 10 or fewer homes within 220 yards of the pipeline for any given 1 mile stretch. Class 2 is generally defined as having 11 to 46 homes or apartments within that same 220 yards of the pipeline for any given 1 mile stretch. Class 3, 46 or more, or areas of public assembly, such as churches or daycares or schools. Class 4 is where buildings of 4 or more stories are prevalent. So Class 4 is pretty much an urban area. And the reason those are important is they determine the depth at which the pipeline is buried. And we'll go into that a little bit more. Now, the basic components of pipeline, you've got your right-of-way, and that's what you see there. And then there's a construction right-of-way versus a permanent right-of-way. For example, on our 55-mile pipeline, which was a 12-inch pipe, compare that mentally to, say, the 36 to 42-inch Atlantic Coast pipeline. Our construction right-of-way, which you're looking at in that photo, was 75 feet. And then the permanent right-of-way will be 50 feet across. So that is the negotiated right-of-way for the pipeline. Then there are access roads. Those can be temporary or permanent. Some are going to be temporary for construction. Others are going to be permanent. They have to get at the pipeline to do certain things over time. There are laydown yards. Those are temporary. They're just associated with the construction part. That's where they store things like the pipe and other equipment, is the laydown yards. Then there are the ATWS, additional temporary workspace. Those are just, they're sort of like laydown yards. They're just additional workspaces along the pipeline path. In our case, those ATWSs ranged from 1 to 18 acres in size. There are compressor stations. Typically, the pipeline builder purchases the land the compressor station is on. We're not going to talk a lot about compressor stations. They have their own air quality and noise issues, but that's not something we have deep knowledge of. So we're not going to go into that a whole lot. But there are a lot of issues, particularly with the larger ones that are associated with like the Atlantic Coast Pipeline. Those can be very big. But compressor stations are located typically every 50 to 100 miles along the pipeline. And of course, they do what you think, they boost the pressure. And the pressure along the route is between 200 and 1500 psi. Our 12-inch pipeline is 1200 psi. So just for comparison purposes, there are valves and regulators. Valves control the flow. Valves can be manual or automated. These days, you really want them to be automated. If you have a pipeline accident, then you want an automated valve so that you can remotely turn that thing off as fast as possible. There have been some accidents that have been prolonged because no one could get to the valve to turn it off, to isolate the whatever is flowing out of the pipeline. So I would assume that most valves today are automated, but there still may be some manual valves out there. And then pig launchers and pig receivers. This is my most favorite term. It's just the little place along the pipeline where you can put in a pig and shove it through the pipeline, and it runs the pipeline, and then it's received on the other end and taken out. It's kind of, once you know what a pig is, it's pretty self-explanatory, but those are great terms. A city gate. The city gate is where it's the distinction between the transmission line and then a more localized system. It's where the gas comes off the transmission line and is reduced in pressure to 200 psi or less, and then it goes into your local transmission system. As I already said, the pressure typically along these interstate natural gas pipelines is between 200 and 1500 psi. Now, process. This is the overview. The pipeline construction process starts with clearing, grading, and trenching, and then stringing, welding and coating, lowering and backfilling, and restoration. Now, this was an interesting situation. This is where the pipeline did not have permission at this point in time to go ahead and cross this property here, so it just stopped at the edge, but until they did get permission. But this is what basically the right-of-way clearing looks like. Just plows right on through, and then the trenching. And they just use typical land clearing equipment for this, the usual stuff. The trenching, typically backhoes. The trenches are at a depth of 30 to 36 inches in a lower consequence area. They can be as deep, so that's basically 3 feet under in an ordinary place like this one in this location here. This is obviously a low HCA. It's going to be 3 feet under, and that'll be relevant visually in just a couple of minutes when I show you one of the problems we had. And then it can be as deep as 5 feet down if warranted in a high consequence area. Stringing, bending, welding, and coating. Stringing is the process of laying those segments out. They do it in sections. They don't, for example, they don't grade the whole thing and then trench the whole thing and then string the whole thing. They'll do it in manageable sections that make sense to the topography that they're dealing with and to what they can manage at the time. And pipe segments are 40 to 80 feet long. and they are fabricated in steel rolling mills. Oh, and they actually bend them in the field. You can actually, you think of a steel pipe as being something very stiff, but they actually can be bent to a certain degree in the field. And then what you're seeing, and then they're welded, the pieces are welded together. You see the welding on the left. What you see on the right is an X-ray of a weld. They use a device something like this, and they are supposed to X-ray each and every weld in the field and make sure that the weld, because that is the weak point in the pipe, is the weld. So they're supposed to X-ray and document every single weld in the field, and that's what that device there is. And then you lower it, looks pretty much like this, and you backfill. And then once all that is completed, you get to the hydrostatic testing, the restoration, and I'll tell you just a little bit about the cathodic protection. Hydrostatic testing is basically once the pipeline is in the ground, they pressurize it and blast it full of water. They're checking for leaks. They do have to have an MPDES permit for this, but that's how they test it. And they also, I mean, they're typically drawing water from some local water resource, surface water, if possible. So they'll hydrostatically test the whole pipeline, and then restoration takes place. Something to watch for is how quickly restoration takes place. There typically are not very, very specific guidelines about this. And that was a problem in our situation, was restoration did not take place quick enough, and damage resulted because there was a lot of exposed dirt. And then cathodic protection. This, every pipeline, in order to, they have a coating on them, and I'll talk about that coating a little bit more in a few minutes, but they also have a cathodic protection system. And this system uses a direct electrical current to counteract the normal external corrosion that occurs on a metal pipeline due to soil and moisture conditions. And when I first learned about this, that seemed sort of shocking to me. You're going to put a current next to natural gas. But the flash point for natural gas is much higher than this current is. So that is the sort of a wire that runs all along the outside of the pipeline, running the length of it with periodic access points to power and to monitoring. So that's another way that they try to prevent corrosion on these steel pipelines once they're buried in the dirt. Now, pipeline water crossings. There is open cut crossing, and then 3 methods of dry ditch crossing: dam and pump, flume, and HDD. Open cut is what we call a wet crossing. There's no stream diversion. The pipe is installed while the stream is running through it. And as you can imagine, if there's a lot of water, the sedimentation could be substantial. These types of crossings are what you look for as the pipeline is being permitted. You need to know what your water bodies are ahead of time. Know what the flooding characteristics of an area are. The more you know before you start this process of intervening or monitoring a pipeline construction process, the more you know what to look for. As I said, we were learning as we went. So this is open cut. If you see in the permit application, open cut crossing, this is what they're talking about. Now, dry ditch crossings. With dam and pump, the stream is dammed and the water is moved across the site via a temporary pipe and a pump if needed. Now, some states, I believe West Virginia, have their own stipulations on the Army Corps of Engineers nationwide 12 permit that states that these types of things must be completed within 72 hours. Other states don't have anything like that. I don't think South Carolina does. So that can be a big issue, is how quickly these disturbances are completed. You want them done as fast as possible so that you minimize the impact to the stream. But in this case, it looks like they're pumping underneath or pumping over, but you can also, most of the time, but I couldn't find a good photo of it, the stream is pumped around the site through a flexible tube around the site. And then dry ditch crossing, a flume crossing, the stream is dammed and a culvert is installed, and you can see in this picture they're going underneath that culvert. I've also seen instances where that flume didn't look so much like a water ride as it does more like a container, like a shipping container open at both ends. And then they go underneath that. So that's another example of what a flume crossing might look like. And of course, with all of the above, the impact on the benthic community is going to be very significant. That's a lot of disturbance there. Can you imagine all the little mussels and crayfish making their way down that flume, along with their natural, what they feed on naturally? It's not going to happen. So the benthic disturbance is pretty significant in addition to the sedimentation. HDD is going to be the preferred method, as will be obvious, is going to be the most expensive method. But what they do with HDD is, and then I'll show you what it looks like when it's done. First, they drill a pilot hole along a planned directional path underneath the water body. And they can also do this underneath highways and underneath railroad tracks. This is pretty much how they go underneath anything that is significant, that they can't have surface level trenching. So they cut a pilot hole, and this is controlled via surface monitoring. And then the pilot hole is enlarged to accommodate the pipe, and that involves using a hydraulic cutting with drill bits and jet nozzles and hydraulic motors or mud motors to cut the harder soils. And they may have to repeat this process several times to get that hole big enough. They usually want it 12 inches bigger than the pipe being installed. And then the pipe is fed and pulled through that hole. Again, this is kind of hard to imagine. It's a steel pipe, and you see it's bending, but that's what it does. And that's how that works. And then when they're finished, the reason this is the preferred alternative is this. You don't have any disturbance along your riparian buffer, unless there's some erosional impact coming off the site that then does flow down to impact the water going in the middle or the wetland going in the middle. You still have that riparian buffer, all those trees, everything's still in place. So this is by far the preferred water body crossing technique. It is going to be the most expensive, and so it's going to be resisted. We were able to get one of our creeks added to the HDD list with ours, and that is a very sensitive creek, so that was a good thing. So that's what HDD looks like when it's done. Now, problems. With those x-rays, because there's such an emphasis on getting construction completed, the contractors are, I'm sure they are rewarded for being quick. There can be the issue of falsified x-rays, and that has to be monitored typically the only way that's found out is through a whistleblower on site. Although if there are other reasons to suspect, then there is typically somebody who's responsible for quality control and inspection along the pipeline route. There is an inspector. They're contracted by the pipeline company, so take that with a grain of salt. So falsified x-rays are at the welds are one potential problem. 2, 3, and 4, I'll go into a little bit more detail on coating deterioration due to exposure, ECD, erosion control device failure, and then post-construction issues. So coating deterioration. The NRDC has noted problems with pipeline coatings. These are coatings that are there to prevent corrosion. But these coatings may break down if the pipes sit for a while. From an October 10 NRDC article, they noted that in a 2009 technical brief from 3M, some of the epoxy resins in fusion bonded epoxy, FBE, coatings have a poor ultraviolet light resistance. And the coating, they noted the coating could also be removed by wind and rain. And the National Association of Pipe Coating Applicators, yes, that is a thing, recommends not storing pipe in excess of 6 months without additional UV protection. Now, the date the coating was applied is stamped on the pipe. So that is an issue that needs to be monitored. And that, like that, for this particular pipe, they said that stamp is from 2017, and it has obviously been in the field for over a year. ECD failure, erosion control device failure. This was from our project, and this is in Spartanburg County. These are two different locations here. Picture on the left, you can see there's silt fence and silt socks that have just been inundated. This was not even one of our hurricanes. This was a very heavy April rain that did this. And the issue here, especially, is that this crossing was completed in January, and it was still sitting raw in April. And so this significant sedimentation event happened. The picture on the right, you see that gully, that silt sock has just dropped completely into a gully that was formed by the stormwater. The pipeline itself is where those 4 yellow poles are, and that is a small stream, might be an ephemeral stream, but you can see it looks nothing like a stream now. It's completely sedimented in and grassed over, and so you can really see what we're talking about as far as sedimentation. And in this case, a water utility downstream was severely impacted by this sediment event. And these are the ones you have to look out for, these tiny streams that they, probably are, they're never going to consider using HDD on. So this is what can happen if the crossing isn't conducted quickly and the restoration conducted immediately after. You've got major sedimentation, major benthic impact, just a big mess. Now this was really interesting. This is where the pipeline popped up. This pipeline, I got to visit this site in Spartanburg County in 2017, and the gentleman who showed me the site had lived on the property since this pipeline was put in, and these are his photographs. That old one on the left is his photograph of the pipeline. This is an 8-inch line being laid. And he said what happened was, in the middle photo, they had to blast through a little bit of rock. And what happened was, when they did the hydrostatic testing, it popped up. It jumped out of its channel, and they never put it back in. So, and now they've got it marked with a sign that says exposed pipeline, but they still haven't reburied it. So you have a high pressure 8-inch natural gas transmission line fully exposed. to the elements there due to pop-up, which is, that can happen when there's hydrostatic testing. I would hope that it happens less today, but again, these are in remote places, so it's hard to know everything that's going on. Although monitoring today is a lot more helpful, which we'll go over next week. Ways to visually monitor a pipeline. And post-construction erosion. This happened again. The pipeline was placed into service. This was probably completed in early 2018. The pipeline was placed into service in March. That yellow line, that yellow pole, is the center line of this 12-inch, 1200 PSI pipeline. And as I was driving along, looking at various sites, I got out and inspected this. That gully is a good 12, 15 feet deep and is continuing to erode into the pipeline's right-of-way. And so that had not been noted in any of the inspection reports. I mean, that gully was just going to continue. It's water does what water does, and it's not going to stop. So that was something where it needed to be reported, and I reported it ultimately to PHMSA. It's now in the record. It can be monitored, but those types of things where you might have a gully encroaching from the side into the pipeline, that ultimately, if it's an area where nobody can see anything, it could undermine the integrity, particularly if it undercuts the pipeline, it undermines the integrity of the pipeline and can be a safety issue. So if these are just to have handy, post-construction safety regulation is handled by PHMSA, which is the Pipeline and Petroleum and Hazardous Materials Safety Administration, Pipeline and Hazardous Materials Safety Administration, Office of Pipeline Safety. And they don't really have a lot to do with construction, but they do take over with the safety issues, particularly investigating events after the pipelines are operational. And then there's a little bit of authority delegated to the state. In South Carolina, that is the Office of Regulatory Staff. It just sort of depends on where it gets put in each state. Might be with the Public Service Commission in other states, but for ours, it's in the Office of Regulatory Staff, and they can inspect and regulate, but they cannot enforce safety issues. So it's part of the problem is that there are so many different agencies that are responsible for different pieces of the pie. And of course, your environmental organizations are going to be involved in the issues that have environmental impacts, such as the sedimentation. Now, Dekatherms, what we've all been waiting for. One of our biggest challenges with our pipeline was understanding how big it was and getting a grip on what exactly it was going to serve. Why was it being built? The application talked about the anchor shippers and how much they wanted, but we really wanted to understand what that meant. Typically, you're going to see natural gas communicated in terms of billion cubic feet, and that's volume. But then you'll see decatherms, so many decatherms per day. And it can be confusing going back and forth, understanding how one relates to the other, and then what kind of visualizing the size. What does that mean as far as size? So a pretty simple conversion, 1 billion cubic feet per day is about the same as 1 million decatherms per day. You move the decimal. So that's just the standard. Keep it in your pocket. The Mountain Valley Pipeline, for example, is being built to carry 2 billion cubic feet per day, or to provide 2 million decatherms per day of energy to the various contractors. The Atlantic Coast Pipeline right now is being built to carry 1.5 billion cubic feet per day, or in energy terms, 1.5 million decatherms per day. Now, just because it's built to this capacity right now doesn't mean that capacity can't change over time. Compressor stations can be changed and upgraded, and I've seen it stated that the Atlantic Coast Pipeline could easily be upgraded to carry as much as 2 billion cubic feet per day, or 2 billion decatherms. So that's pretty simple. Ours are and those are 42-inch, 36-inch pipelines. It just sort of depends on where they are as to how big they are. Those are big. Our smaller pipeline here in the 55 miler is 12 inches, and it is 80,000 decatherms per day. So, and I'll talk a little bit more about decatherms. So, how many decatherms do different uses use? A 500 megawatt power plant, and that's actually a pretty big natural gas power plant, would require 84,000 decatherms per day at peak, running at peak, not all the time. Industrial users range from as little as 30, 50 decatherms per day to about 3,000. Then you're going to jump into a much larger category. I've seen one that needed 50,000, but they were making their own CNG, their own compressed natural gas for a fleet of trucks. But typically, a large industrial user is going to be about 3,000 decatherms per day. And then 1 million decatherms per day can fuel 5 million homes per day. So your little home is about 0.2 decatherms per day. So when you see an application and they talk about the different anchor shippers, you can kind of look behind that and make sure that makes sense. Is an anchor shipper a power plant? Is that power plant actually going to get built? And of course, it's going to differ between whether it's a combined cycle or a combustion turbine. It's going to differ, but this is just a generalization. And this is a combined cycle plant that I believe that I'm looking at. Now, for the bigger picture, for example, South Carolina has about 900,000 decatherms per day contracted capacity, all through Dominion Carolina's gas transmission. But generally, it uses about half that. So just kind of, if you think about the Atlantic Coast Pipeline being 1.5 million decatherms per day, or the Mountain Valley Pipeline being 2 million decatherms per day. And then the entire state of South Carolina, which is a pretty manufacturing intensive state, uses maximum right now 900,000 decatherms per day. And that's like one day a year when that level is pushed. And that's probably like the coldest day of the year when every gas plant's running full throttle. So those are just things to think about with respect to capacity and the size of a pipeline that might get proposed. Exports. This is something that's not gotten a lot of attention in the past, but it certainly will very soon, and I'll show you why. This is Elba Island in Georgia. This is an LNG. It had been an LNG liquefied natural gas import facility. It is currently being modified to export, and that is a growing factor. So liquefying natural gas for export, what you do is you drop it to minus 260 degrees, and by doing that you can reduce 600 cubic feet to 1 cubic foot. And then there's also some purification that has to take place. And one LNG tanker, and that's what they look like right there, holds 3 billion cubic feet. Now, these are current import and export terminals. The imports really don't matter. We're not really using them right now because we're producing so much ourselves. But right now, these are existing export terminals, and I will draw your attention to that B. That is Cove Point. In Maryland, the rest, Sabine Pass, the closest one that's currently in operation is Sabine Pass down in the Gulf of Mexico. And Cove Point just recently came online. That was specifically built to be just an export terminal, not a. I don't believe it was ever no, it was an import terminal. Okay, but that one was the second one, kind of in our area to go online, and then Elba Island will be coming online, which is C at the end of this year. Now, notice the length of that list right now. Export terminals, I've got it marked with the blue box, export terminals. There are right now 3 existing. This is what's been approved. Approved, and some are under construction and some are not. And you can see there's Elba Island. Our construction of export terminals is growing dramatically. And so, and actually we became a net exporter of natural gas in 2016, where that star is. That's when the United States became a net natural gas exporter, which is, for those of us who are old enough to remember the 70s, and oil embargoes and things like that, and OPEC, it's kind of an amazing head scratcher to think that we're now a net energy exporter on natural gas. Now, a lot of it is going by pipeline to Mexico, but for that which is going by ship, where is it going? Right now, South Korea 18%, China 15%, and then the next largest importers of our natural gas are Japan, Turkey, Spain, and Jordan. And U.S. export capacity is about 3.6 billion cubic feet per day right now. And next year, when a couple of more terminals come online, it's going to be 9.6. So it will triple in a year. And then it'll keep growing after that. And then our third, we will be, by 2020, we will be the third largest exporter behind Australia and Qatar, which is pretty amazing, I think. So why does this matter? Price. All right, this is one of our wordy slides, and I apologize for that, but this is important stuff here. This is a group called the Industrial Energy Consumers of America. They represent the large energy consumers nationally, and they have a particular category that they call energy intensive trade exposed industries. So basically, companies can get a lot more money for natural gas from foreign customers than from domestic customers. And so as our export capacity continues to build, that's going to put price pressure on our natural gas, and it's expected to raise domestic natural gas prices. And this organization basically said, this is from their comments to the U.S. Department of Energy in July of 2018. When we export natural gas, we are lowering the cost of natural gas to our manufacturing competitors in other countries and increasing our domestic costs, a double negative impact. You're making it harder for us to compete, invest capital, and create high-paying middle-class jobs. And then they go on to look at the jobs analysis, which I also thought was interesting. The oil and gas industry employs about 512,000. Manufacturing employs 12.7 million. And of that, those energy-intensive trade-exposed industries employ 5.1 million employees. So the impact of rising prices, the impact of all of this export is going to be pretty significant. So that's something that we will continue to keep an eye on, and will increasingly be in the news, I'm sure. Now, for our last section is navigating the EIA, the U.S. Energy Information Administration website. We did the FERC website in episode 1. The EIA website is also a fascinating one. This one's just fun to play around with, and it's a source of a lot of data. In order to see what our current energy infrastructure is right now, you go to the maps. And for that, you start with geography. And that's that drop down, it's a geography at the top. And then you look for U.S. Energy Mapping System. And then that pops up this very, 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 very cluttered map. And it's too much to look at, but it has layers. And you can turn those layers on and off. So if you click on those layers, you see all those things. You can turn them on and off. And you can look at just, just natural gas infrastructure. And there we are. Now, the interesting thing here is I keep checking on this. And our 55-mile pipeline that was completed and put in service in March still doesn't show up on this map. So in South Carolina, but everything else seems to be there. You'll notice the Atlantic Coast Pipeline and the Mountain Valley Pipeline are not on this map because they aren't completed yet either. So there's the interstate natural gas pipeline infrastructure per the EIA website. And then you can see those the pipelines that go down to Elba Island. And you can turn on more than one layer at a time. We can look at, ooh, that's solar. See how many solar installations are. This is it's very interesting to watch the solar change over time. South Carolina is not looking quite as good as North Carolina right now, but hopefully that will change over time. Now, I'm going to see if we have any questions. Yes, we do. All right, let's see. Okay. All right, our pipeline, Dominion, the one that was recently installed around Clinton. Yes, exactly. That's it. Transco to Charleston. Are they always buried? Pretty much. Yeah, pretty much. These days especially. I don't, the Transco to Charleston was definitely buried all the way. I don't know if they would. I can't even think of an incident where they would want it to, go under a bridge or something like that. I would think that they would always be buried for safety. Okay, why are the pipes on the left and the stringing and coating two different colors? I would assume, I'll go back and look at that, but yeah, probably just two different colors, but we'll go back and look at that in just a second. Cathodic protection, is that done once during pipeline manufacture or during installation or constantly while it's in use? The cathodic protection is after the pipeline is laid in its trench, the line, or either before or after, at that point, the line is laid along the exterior of the pipe. It's not something I understand in detail, but the little electrified line is run along the exterior of the pipeline before it is backfilled. And then it's connected to control panels at various points along the pipeline. Of course, they have to check to make sure it's always working. And it has those monitoring points have to be connected to electricity. Okay, for the slide deck, the understanding flow and use slide, because you use those things spelled out. Okay. Okay. Also along those lines, the where is it going now slide about our exports would be nice in the future to have a date instead of now. That's a very good point. I should put, yeah, and now is 2018. And that can change at any point. So I will, for the purpose of archiving the slide deck, I will absolutely do that. Those are great suggestions. So let's see if I can go back and just double check with the pipes, the stringing. Can look at all these pretty pictures again. Yeah, yeah. To me, I can see the green. I think it's weird, just different pieces of pipe and weird angle. Although maybe they're two different company coatings, I don't know, but I can kind of see that green on the left. I would assume though they're pretty much the same. But yeah, maybe it's just got something on it. I don't know. It's a good question. Alrighty. Yeah. My question asker said, I hope that's not the sun bleaching it. Yeah, exactly. Given the problems with exposure to materials, that's a very good point. All right, if there are no more questions, then we can finish early and everybody can go on about their Monday. And I will, as always, this recording will be downloaded generally by tomorrow. I have it available to put up on our landing page, our pipeline landing page. And then I will send out that link again. Apologies to those of you who keep getting the same link. But that's thanks to you for sticking with me for all of these. And then Wednesday, David Sly will be back. He's going to talk about some neat various monitoring programs that are underway, for example, in Virginia. They're doing some really cool stuff with drones up there. There is a neat organization called South Wings that helped me with this pipeline. I flew South Wings twice to monitor this pipeline. Katie Huddle will walk folks through. It's going to be kind of a high-level explanation of how we use GIS to identify individual property owners along our 55-mile pipeline that may or may not be useful for your organization, depending upon well, what you're doing with respect to pipelines. But if you do want to find out who is along, this is how you can do it. And then you would need a GIS expert to. You should have enough information to tell your GIS expert what to do next. And then we're going to talk about conservation easements and timber easements. And the timber, I thought, the impact on timber and the timber right-of-way negotiations, I thought were particularly interesting for how it impacts timber properties. And in the Southeast, we have a lot of timber properties. So I hope that will be useful. And I'll double check, make sure there are no more questions. Okay, and that's all for today. Thank you all so much for hanging in there. I hope this has been helpful, and I hope to see you back on Wednesday for our last, fourth and final episode of Pipelines 101. Thank you.